Good afternoon. Good afternoon again to those who were at the previous session and have to endure me a second time. So I'm going to skip my presentation. Welcome to the model validation panel. And before we get into it, let me introduce them. Well, actually, let the panelists introduce themselves. Easier that way. I don't have to remember everything David has done and others have done. So go ahead. Let's start with you, David.
Sure. Yeah, hi. David Palmer from the Federal Reserve Board. I'm in the Division of Supervision Regulation. I've been there for decades, quite a while. But I've worked on a number of things. One of my favorites is model risk management. It was one of the authors of the model risk management guidance that came out in 2011. But I've also worked on other things, capital, more recently third-party risk management, the guidance that came out last year. So, have my fingers in lots of pies, as they say, but I like that. And it's fun to see when things have synthesis among them. So thanks very much for the invitation. And we have a great panelist here, so I'm really excited for the chat.
Thank you, David. It's always fun sitting next to David. Many of people in this room owe deeply to David. He's the father of SR 11.7 and model risk management. So my occupation the last 10 plus years was created by him. So do many of your occupation in this room. My name is Agus Sugianto. I'm the head of model risk for Wells Fargo still until today. By the end of the month, I will be a free person. I will be retiring. So.
End of an era.
Yeah. Hi, everyone. So I'm actually a model builder. So I create all those models that all of you have to manage the risk for. I'm at Virtu Financial. I started out my career in big data science about 5 or 6 years ago. Our group has already been producing standard econometric models that are covered under the existing regulation, but we moved heavily into ML and AI-based tools. I'm really excited to kind of hear what everyone is saying they need from model builders, because that's important for me to hear, and I'm going to hopefully give you perspective as to what we're trying to proactively provide out, especially around our ML and AI models, so that everyone can use them effectively and efficiently.
Good. And so I'm Evan Segers, and I just realized that a bunch of you were not in the other session, so I do owe you a quick intro, just in case. So Evan Segers, right now, I'm in the exact opposite boat of Agus's. I'm a free agent until Friday, and then I have to go back and actually work. Starting Monday morning at, they just texted me that it's going to be 7:45 a.m. as opposed to 9, whatever. It is what it is. I've been for about 20 years in the operational risk, non-financial risk space, actually. That's where I met David in my early days when I was at the Fed. I was there until 2013, and then left the Fed, moved into a few consulting roles, always in the non-financial risk space, and then landed in model validation at PNC, and after that as the head of non-financial risk for MUFG, and then as of Monday somewhere else. With those introductions out of the way, let's get started with the panel. We did prepare, but this is like herding cats, especially with those two.
Yeah, I felt like I was really available.
Erin is much more, she's a modeler. So, well, although Agus is an engineer, so he's also very linear. But I'm going to try to manage this in a very flexible way. So we can, I'll try to set the stage, and then we'll try to stick to some of our points and see how close we can stay to them. Good. So the starting point really ties back for those of you who were in the previous session. AI is becoming a big issue at most banks. I'm repeating what's been said probably 2,000 times today. From a model risk perspective, it's really raising a a number of new problems. And I like to bucket it in two broad categories. One that is the more of a governance issue, and then two, a second category, which is a category that's more on the validation side and a more technical side, from a more technical perspective. So the way I try to think of it is there are all the traditional models, and by that I mean the forecasting models, which SR 11.7 really was written for, right? Because at the time, 10 plus years ago, those were the bulk of the models that we had to use, and those were the risks we were trying to manage. And we're not going to debate how many angels dance on a pin. That's not the thing. I agree with your view, which is that there's a simple definition of a model. Do we use data? Are we making assumptions? Is there some kind of processing engine? And do we have uncertain forecasts, right? You have those elements, you have a model. But while originally models were this very well-defined set of objects, now that definition applies to a much larger number of items that have to be, which risks have to be managed at banks. And that poses new challenges for MRM and model risk and risk management in general. And going back to a point that David was making earlier, it doesn't mean that because it's a model that they all have to be managed the same way. And so part of the conversation will go there. So we have one bucket of items which are what I would call our traditional models, forecasting models, and how does AI change the validation of these models, right? So think of credit models, market risk models, CCAR models, whatever you want. The models that are in your inventory now, and you're slowly starting to adopt ML techniques. And so this raises a bunch of new problems for model validation, and we will talk about that. But then there's a whole new category of problems, which is the second big bucket, which is AI/ML now allows you to use models in completely novel areas of your bank, areas where models were not, could not be considered in the past because of the type of data you had. And I think mostly of unstructured data and the ability of AI/ML models to process unstructured data. So you will have this proliferation of models at banks, but in areas where it's a completely novel use of models, and where models might not be doing the same tasks, quote unquote, as they're doing in the more traditional space, which is forecasting or strategic decision support. They might be there to help you automate tasks. They might be there in a support function. And so now that creates a whole new set of problems, which is, what do we do with these models? Do we validate them the same way, or do we have to come up with different ways of validating them? Or, and Agus has some interesting thoughts on that. We'll get to that. So those are the two big buckets, and I would like for us to basically touch on both. And so I thought that maybe we start at the higher level, which is, what falls in each bucket, and maybe quickly talk organizationally what we can do with all these models that are the new crop of models, and then we'll come back to ML models that are coming and replacing the more traditional econometric models, and talk about all the issues of bias, explainability, and such. Good. And so with that, my first question, well, it's easy. I'll go with David, which is, how do you think about this problem of the new models and how institutions should organize themselves to tackle that problem?
Yeah, thanks. Obviously, super interesting topic, which is why I always jump at the chance to talk at events like this, because it's an intellectually stimulating discussion for me, but also I learn a lot from, not just from panelists, but talking to others here. So thank you for that. I think what we, first of all, we're really trying to avoid being kind of dogmatic about these things, or as Evan said, sort of, we have a general definition of model in our model risk management guidance. If we talk to institutions and, they have a definition that's similar to that, and they have something in their organization that generally meets that definition, we will ask the question, well, and they don't call it a model, we will say, well, why is that? Why is that the case? And several years ago, we did have some instances where a couple of institutions decided to put a different label on things that were clearly models because those got a lighter touch. And we called that out, and we said, all else equal, they should get similar treatment, whether you call them this or call them that. But if it's a sort of form of definitional arbitrage, that's a concern. But generally, we try to take a flexible approach and say, firms can have slightly different definitions of what's models. To Evan's point, very importantly, even if something is called a model, they can address it or have different types of risk management controls, customized to their own organization. So we try not to say, these things have to be models. And I think AI is a great case. We have not said definitively all AI are models. The extreme case that I often use is we know that in some cases in banks' buildings, they have elevators that use AI to make the elevators more efficient. Am I going to say those have to be put through the MRM program? No. But I hope there's some controls over them so people don't get stuck in elevators, so there aren't elevator accidents, and that they actually, go to the right floors. So that's sort of an example of how we can be flexible of, having risk management controls over something, but you don't necessarily have to put it in your model risk management framework, or even if it is in your model risk management framework, you can have different approaches to it. And we've seen some organizations have a slightly narrower definition or have a sort of a narrower approach to the purely kind of statistical, quantitative models. Then they have a different part of their MRM program that's devoted to qualitative models. So they're still producing quantitative output, but a lot of what's going on in terms of the processing is more qualitative in nature. Again, what we want to just confirm is that they're, the proper risk management controls in place. When it comes to AI, these are things, we're talking about, we're having a good conversation with industry about are, what are some of the particular factors that drive AI validation, validation even in the pure MRM sense, or validation in the broader sense, or independent review. And so things like data governance, things like making assessments of the output, being able to assess performance, looking at whether there is consistency, robustness, whether these things actually translate from the training environment to the real world and so forth. And I'm sure my colleagues fellow panelists will talk about these in a little bit more detail, but that's sort of the general approach that we're trying to lay out. And we're seeing, at least so far, that most of our supervised institutions are putting most of their AI approaches into their MRM framework. One, because I think it's kind of convenient for them. They have these frameworks already in place. But I think they're also seeing that a number of the principles from their frameworks, a number of the factors they look at in those frameworks have applicability to AI, even if they look at them slightly differently. Mm-hmm. So I'll stop there. That's sort of an overview of how we're approaching the issue. Arus?
Yeah. Probably I'm going to divide it into two parts. The predictive AI that we know very, very well, that we have used it for quite some time, particularly on tabular data. We know how to deal with that. About a couple of years ago, myself and my team released a tool called PyML. That's how you get explainability, some of them exact explainability, and testing for many, many different aspects. So that's predictive AI, particularly for tabular data. I would consider it a solved issue. We know how to deal with it. And then the next part is what I want to focus is on large language model and generative AI, and how do we look at this. I'll start with large language model, because how do we use large language model today? We use it for text classification, complaint routing, monitoring of traders' behavior, and all of those things. Or we use it as information retrieval, asking questions to retrieve information, so very nice productivity tool, or retrieving information plus summarization, what known today as retrieval augmented generation, and general question and answer. So if you look at all this, particularly the generative AI today, is no more than predicting the next word. It's autoregressive model. If you have autoregressive model, you will validate it. Every autoregressive model in tabular data, you will validate that. So you have now, it's the same concept of autoregressive predicting the next word through complicated feature engineering, because you have transformer layer, you have complicated variable transformation through transformer, and then you do autoregressive model. If you validate simple autoregressive model on time series tabular data, you should validate the autoregressive model on language model too. Because the danger of this, it can be very dangerous. For example, we use it in the banking center to assist banking center to answer customer question. And this model, known as like any autoregressive model, the longer to predict, the uncertainty will be bigger. Same thing, we call it hallucination, right? But exactly the same thing. So the danger, the person can get wrong information and providing wrong information to customer. Suddenly you're dealing with UDAP problem. So that kind of risk is out in there. So we have to validate it. And then when we say validated, what does that mean? I think David wrote very, very masterful document in SR 11.7, talk about conceptual soundness and outcome analysis. Yes, we have to look at conceptual soundness and outcome analysis too. There are some unfortunate things because most people use foundational model, which conceptual soundness can be questionable in terms of, because when we talk about conceptual soundness in tabular data, we talk about the data suitability, data quality and suitability, which language model have the same issue. We have variable selection in the tabular data. In language model, we have prompt engineering, which is the same thing. It's input that we need to validate. We need to have explainability, explaining input and output, which in language model we can do it too, because every information translated to embedding in representation, and we can look at the embedding of the answer, embedding of the prompt, how they relate, so we can understand an input and output relationship too. Then we do benchmarking. Yes, we do benchmarking too on language model. So conceptual soundness that applicable for predictive AI, it will be applicable for language model too. And then outcome analysis, same thing in outcome analysis. We're looking at what condition the model is weaker. We're looking at the weak spot, weak condition when the model performance is less. So we do the same thing in what cluster of information or prompt that the model will perform less. We look at the reliability, prediction uncertainty. And this model, particularly large language model, is notorious in terms of prediction uncertainty. You give prompt, the same prompt, you get different answer. You get the same prompt, you get different answer. So it's very notorious on the prediction uncertainty. If you look at the under the hood, look at the probability of predicting the next word, it vary a lot. And you look at the embedding, it vary a lot. So prediction uncertainty is a humongous problem in the LLM. Then we talk about robustness. It's the same thing. How sensitive the model to small perturbation in the input. Language model is very notorious. You change it a little bit, the answer can be very different. Yes, you have to test for robustness. And then we talk about test for how the model going to perform under distribution shift. Yes, people use language model asking different questions, so it has distribution shift that need to be tested as well. And those are the same element that we have to test. So the principles are the same, the techniques will be different, the metrics will be different. Instead of for information retrieval, metrics very similar, summarization will be different. You have hallucination, toxicity, and all of this. The metrics will be different. But all the steps, the principle are the same. So that's, and for me, it's a bit appalling today, honestly, when somebody have a software, you will always test your software before you deploy it. Now you have Gen AI, you don't even test it. And this is a lot more complicated than software because it has stochastic nature and all those things. So testing testing software is not enough. You have to really test the model. So that's the thing that we're dealing with today. Suddenly, people just do Gen AI without any testing and deploy it. Even the big company, the hyperscaler, like Google, misstep. So that's kind of things that I'm concerned about. And I think as a community, we need to up our skill to understand how to validate this model.
And before I pass it on to Erin, just a quick question on that, because these are models that are not part of the core competencies that you will find at a financial institution in the modeling space, right?
It's not true.
Not necessarily. Well, it's becoming less and less true. So we're building up that community. But there is really the question of third parties, which we were discussing earlier, which is when the model, the Gen AI model is not in-house, is not built in-house, and it's a vendor model, you might not, and oftentimes you will not have access to the model itself in order to be able to do that kind of validation. What do you do in that case? Because you still need to ensure, you want to use a service.
Right. I think it's the same thing. We deal with vendor model all the time today.
Right.
And we know how to validate vendor model today. Yes, we're not going to know what's the inner detail and all of those things. But we can still test. We can still do benchmarking. We can still test for model weakness. We can still test for robustness. We can still test for reliability or model uncertainty. And we can still test for distribution shift. Just like we're dealing with vendor model, we may not be able to go detail on the conceptual soundness. But we can still do testing. Mm-hmm. And rely a lot more on that. But most of the model, even in the third party, they may even provide the embedding information. So like OpenAI and all those things give embedding information. It's also give the probability of predicting the next word, that you can get the information and you can test it. Sometimes it's completely, your vendor probably completely not sharing with that, but you can still do all those outcome analysis testing and relying on the outcome analysis.
So it's a higher reliance on outcome analysis rather than conceptual soundness.
Right. Yeah, and I'll just add briefly, I definitely want to let Erin get in, is I would just add, there may also be cases, if you're using this in a more material capacity, then you might also want to apply compensating controls for the fact that you haven't been able maybe do that full conceptual soundness assessment. That's not unique to Gen AI. As Goose said, that's a vendor-related problem for all kinds of models. So that's a good sort of natural instinct that we try to engender, that if you aren't able to do that full conceptual soundness assessment, you maybe put more focus on other things like testing, but you also might consider some additional guardrails if you're using it for something more important.
Good. Erin?
Yeah, so as a model builder, I don't differentiate. Everything that I build that is basically trained off of data and is predicting is a model. I call them models. I will call them when you come in, because I'm a vendor. Some of you might consume models from me. I call them a model. And so there's a couple of big differences, though, in application between a traditional econometric model and an ML and AI model. The first is the scale of the prediction. So we have an econometric model that's been out there for 20 plus years, and its goal is to predict market impact of a trade. Many of you might use it in portfolio analysis. It's used in trading. It's used in a lot of places. It falls under everyone's SR 11.7. We have documentation for it. The big difference between that model and the ML model I'm building today is the scale that we will predict off of. So that's an econometric model. It's structural. It does have a calibration component to it. But I will give you a prediction off of a 1,000% MDV stock traded in the Philippines. No one has traded that. I will still give you a prediction, though, for that. In the ML and AI models that I'm building, we highly cap that scale of prediction. So I have another model that's doing the exact same thing, except I've built that using an ML approach off of the data that I have in my observed peer universe, off of my observed trade universe. And that I've said you can only call this for this type of trade, trade it here. So I've grossly restricted the amount of prediction that I'm going to force that model to do. So in my head, as a model consumer, you can do the same thing, right? So the econometric model was built to basically scale, in a lot of cases, off of data it hasn't seen. ML and AI does not have that same structural form. It is not as good at predicting off of data it hasn't seen. It's exceptional. When you have a good training set at making predictions, it's fantastic, but it's not as good as doing those predictions. So when we go out to people, we say use case matters. We think you should only use it in here. In our APIs, we will actually cap you. We will not give you predictions, and we will say we do not provide predictions in this space. So I hope that that helps some of you model consumers in this space. But for us, every model is a model. We are happy to provide transparency. I am a vendor, right? So we get asked questions on everything. One thing in the ML and AI space, because we actually haven't gotten asked for the same documentation around our ML and AI models that we have for that econometric model that's been out there for ages. So one of the things that we've done proactively to hopefully help the community ask bigger picture questions is we publish the data that we've used, but most importantly, the data we wish we had but didn't have. For ML, that's really, really important. All models have bias in them. That's just inherent. You need to understand what that bias is. And in a lot of cases, as a model builder, I'm like, gosh, my model would be that much better if I had access to this. I will give you a prediction in Asia, for example, but my Asia universe is pretty underrepresented. I'm going to let you know upfront, hey, if I had more Asia data, this model would be better in Asia. We will tell you the features, so the inputs that go into our model, and then the features that we actively excluded. We have a lot of endogenous features, so we will say, hey, we actively kicked this out. We think it's too, XYZ, and we excluded it. And then we will also tell you the model algorithm that we used. We, because we are a vendor of models, will err to the more transparent models. So we actively kind of avoid neural nets. They, for a lot of our stuff, only give us slight accuracy boost, and they are the black box of all black boxes. So if I'm trying to convince you to buy a model from me, right, and I say, I can give you a model, and I can tell you everything that went into it and exactly what drove the output, or I can give you a model and I can't explain anything about it, this one is probably the one that you're going to do. And when it comes down to, I think the LLMs, again, I love how you explained everything in my head in the ML and AI space is just a probability of prediction. That's it. And I love how you explained LLMs. They are literally, that's all they're doing is just giving you the word that they think has the best probability in kind of what you had prompted in or what you're asking. So in that space too, thinking about, I think, defining it to a use case, a specific use case can help manage the risk there.
Right. Yes. I just wanted to let you know, please feel free to either ask questions or text me questions here, but let's go to the questions. There was one, let's start and then we'll take the one.
Thank you so much. I love the analogy to ARIMA or autoregressive or time series models. So, because these models have been used quite a bit in econometrics for ages, and often enough, they help you to sort of extrapolate, right, out of the data that is essentially self-learning. Sometimes it's using a price to predict the next price or the next word, and you can really test them but often enough is going to be very much depend on the journey forward and journey back, right? We've done that actually, models with the surprise into the autoregressive, meaning a giant sleeping, creature waking up. So you can actually even add to those, make them probabilistically less predictive, if you want to call it. So how come that is not really used so much in the financial world, or is that just that's just for traders and things like that? It's just not adopted by the bank elsewhere?
Adopting the language model to predict, or adopting neural net structure deep learning to predict?
No, the same approach you calibrate or you understand or you explain your autoregressive model.
Right.
Right? Whatever it is, if you wanted to, for example, regime changing models, like going from pre-2008 to post-2008, pre-COVID to post-COVID. Those are in the financial model prediction, guys. We've been doing this for 30, 40 years, understanding that, if you're using Black-Scholes is not going to capture everything. It's just a calibration tool. Mm-hmm. So traders use these things as an input, not as a prescription, right? So
on the language model is the similar concept. You have the concept of domain generalization. Basically, it's a completely shift. Because typically we do a zero-shot learning. We take a foundation model, then I'm going to apply it to my area. For a specific area, that model may never seen it before. So that's a completely different regime. So we have to test it because it may not be good at all to do that. So yes, the test in terms of, I call it distribution shift, is basically regime change. So how the model will perform under that environment. So yes, you have to test it. Because is the zero shot going to work, or do we need to fine tune? We for example, even the most popular use today, retrieval augmented generation, just to retrieve the information and then to summarize. But if it's your document that you're trying to retrieve is not on the training data set, it's completely different things. And asking question, it will retrieve, because it will retrieve is on closest distance. It retrieved the wrong thing. Did you check it? And then if you retrieve the wrong things, and then sign it to large language model to summarize, did it summarize well? Even the information can retrieve correctly. The language model, because of the autoregressive, it will still hallucinate. It will still possibly draw wrong summary. So those kind of things has to be tested. And then when I spoke about, let's test it under different distribution shift. If the user use question for certain domain, will it work? So yes, we have to test for distribution shift or test for that. Test the robustness. This is notorious in machine learning, any machine learning. Because any machine learning is overly parameterized. You're not talking about a few parameters. You're talking about thousands in this language model, talking about billion and trillion parameters. So you have more parameters than your data. That's given in machine learning. You have more parameters than the data. So the model will overfit. When the model overfit, what happened? With slight small perturbation on the input, you change the word, you change something, it will go off tangent. So that's just the nature of overfit model. And any machine learning, even XGBoost, the traditional one that you use, all of them overfit. You just don't detect it. You can detect it, you can just test it by applying noise robustness. So you see suddenly, this is why we see a lot, machine learning model look beautiful in the lab when you develop it, when you deploy it, crumble. That's very common because machine learning are overfit.
Hopefully not.
I can guarantee you. But I wrote a paper on this.
100%. You always do where it's left away. It takes points, and you go off the edges. You call it
right.
She's not a globally optimized model.
The other thing I just want to add, though, is I think we always try to emphasize that materiality should really play a big role in all of this. So if you're using a large language model or some other type of Gen AI for very important things in your organization, you likely, you really should do a lot of things, that Auguste described or that I ticked off, strong data governance, lots of testing, careful ongoing monitoring, likely at higher frequency and with additional assessments, and checking for consistency and so forth. But by the same token, if it's something that's used at a very low level in the organization, importantly, though, you do want to check, even if it's individuals using it for something that's low risk, if there are thousands of individuals in the organization using it and it's making the same error for them or the error in the same direction, then that could propagate the risk. But, the example I like to use is, Gen AI enabled search engines, right? So we're all using those today. If it gives me a wrong answer, it's all how I use it, right? If I take it at face value and say, oh my gosh, this is the answer, and I'm going to run with this and not apply any scrutiny, I think that's a real concern. But I think it's very important to remember that with these Gen AI approaches, there is a significant principal agent problem, is the way I like to put it, sort of in the economics profession, and it's often hard to detect.
So one big advantage, though, we have in this Gen AI space that we don't have in the traditional econometric space is to build the econometric models. We spent a lot of time and a lot of money. There is a proliferation of available LLMs today. So I think one of the best ways to test an LLM is just to pull in to ask the same answer against 3, 4, 5 LLMs that are all accessible, all built by different companies, all trained off of different data, and cross-validate if those answers coincide with each other. You can't do that for a lot of the traditional models because you had one. Spent a lot of time and money building that one, so you had to come up with all these other ways to test it. But I think the cross-validation, I think that's a pretty easy approach to validating the output of the LLM.
Yeah, that's, I would say, consistent with principles from general modeling, that if you have models that have a higher degree of uncertainty, or you don't have, you have challenges in assessing performance, or you don't have data against which to test performance, you likely try and triangulate around the issue. Mm-hmm. And we've seen that, say, for example, in stress testing models.
And before we move on to the question, something that came up in the conversation that is very interesting to me, especially coming from the operational risk world, modeling world originally. For those of you who were around in the mid-2000s all the way to the early 2010s, when we were building AMA models, the anathema to AMA models was overfitting models with too many parameters. So we were constantly rating banks who were trying to use model distributions with too many parameters. We were trying to limit it to 2 up to 5 maybe. Some trying to do kernel estimations, and we were completely against it. And the reason was very simple, is that if you overfit your data when the objective is to do out-of-sample predictions, if you use techniques that overfit, by definition, you're not going to be achieving your objective. And the reason I'm bringing that up is that there is another element here in model risk management, which is not waiting for the model to be built and validated, but also ensure that there's a good understanding of when certain tools can and cannot be used. Because these tools are, as you mentioned, very easy to access now. And people might be tempted to, I'll use the tool in a scenario that is absolutely not the right scenario, right? And I've seen that happen where it's a sexy thing to do. We're going to build an ML model now, and your data set is still very limited, and you're trying to do projections that are way outside of the range of the data that you have to calibrate your model. You need structural models for that. You need strong assumptions that are clear and understandable to be made so that you can make these out-of-sample projections. And if you're going to use a tool that by design is overfitting, you're going to fail. And I think that is one of the dangers, is that everyone wants to use the latest sexy thing when in some instances it just should not be used. And that's education. But with that, you had a question.
Yeah, I have a technical question again as a follow-up to the autoregressive models, Agus, you mentioned about. So Jan LeCun gave a talk and he said that the LLMs really suck because they are autoregressive, right? Autoregressive models have like exponential divergence as you kind of move longer. And what he kind of suggests is moving to a lower representation state, and he suggests like an architecture called JEPA, Joint Embedding Predictive Architecture, where he says don't use all the information but filter it down to a representation state, which is more refined than the embeddings. Are the banks thinking about that transition which he's talking about, using the energy models from the physical systems and whatnot? Is this being considered in the banks or no?
I think there is research and then the real world, right? So coming from research to real world take a long time, right? So a lot of ideas in that. When I used to design engine, I used to design engine for motor company. We have research group. After research group, we'll go to advanced engineering group. And from advanced engineering group, then come to my group that's doing production, design engine for today. So modeling is something like that too. Which one is ready for today use? Understanding the limitation, but it's still useful. I think that's what the game that we have to do today. These models are incredible. They are very useful if we use it right. But we need to understand the beast and how to control it. Now, the problem that I have is because you're talking about now become easy. You just download from Hugging Face or use API, you're there. The problem, the danger is this. This is becoming now a technology domain, technology project. Then people think that technologies can do moonlighting to become data scientists, can deploy this. This is the responsibility of people in this room. This is not technology game. This is a model risk management game. So I think this is very, very important because it carries a lot of model risk and not just technology, just like software.
And by the way, it's a problem that existed at a smaller scale in the past with Excel, right? Excel was the first tool to make modeling it more accessible. And I've seen that, I'm sure you've seen it at your bank, a number of people who are literally building models without realizing they're building models. And so it's not in the inventory and they're using it. We had traders do that and they're using it for decision making and no one validated it. And not
understanding that Excel has its own limitations.
Absolutely, or that the regression tool, it's a simple linear regression, and it has its own flaws. So it's very interesting because this speaks to the education that needs to happen, right? That model risk is not just there as a cop trying to, at the end, validate things and say yeah or nay. Model risk really should take it upon itself to help change the culture of the bank and help educate the bank as to what is a model, what are the processes, and by the way, make them streamlined enough for the appropriate in the appropriate context, so that people are not afraid to bring their model through the process. Because you were talking about arbitrage, and we've seen that where there's a one-size-fits-all tool, model validation process. And then a number of people are afraid of declaring a model because they're afraid of the cost. And so that's on us to make sure we streamline it so that when the risk is low, we can encourage people to still bring it and not be fearful that we're going to make them lose a lot of time doing it. But education is key. I see a question.
Just chime in on that one, though?
Yes.
As a model builder, LLMs are built to be creative. From the core, they're built to be trained off of data and give you something similar, but not exactly what it's seeing. Why are we killing the creativity? That could just be the wrong use case for that model. If we feel like we need to strip so much out and contain so much, there could just be another approach. We're really restrictive with where we use LLM. There's other natural language processing models out there. BERT is a fantastic one that all of us who have been here pre-LLMs are still using. So like in my head, if we're stripping that much out of an LLM, I would question the use case as opposed to the model.
This is, okay, let's take the question and then I will steal 30 seconds because I do have a final question for everyone.
All right, this might be related to the question, but I agree, Agus, that the principles still apply to GPT models or Gen AI, but I wonder if the scale of the problem like makes you have to create a new paradigm. Like how do you do sensitivity analysis when there's like an infinite range of inputs that you can test, or how do you do perturbation when there's an infinite range of perturbation?
This is very, very important question. If we do open-ended Q&A like OpenAI, I think you shoot yourself on the foot. For us in banking, you will never do anything like that because anything can go wrong and people can make it wrong. But if we bound it, what is the use of the model? Because we always do that. We use model for a specific purpose. Then we bound the input and we bound the output, just like in RAG, Retrieval Augmented Generation. We bound it. If we bound it, then we can do very extensive testing because we can see, okay, what are the documents that we're going to retrieve? We can look the embedding, we can cluster it, we can see it. So we can bound it. Unless you bound it, I think it's only company that crazy enough to unbound it, putting Q&A open-ended like OpenAI. Like Gemini, here's the problem. Because you will never be able to see it because if you unbound it. But this is very, very important. If you care about risk, in some area care about risk, then you have to bound it, you have to control it. Otherwise, you're going to shoot yourself on the foot. Unless you're doing something that's not very risky, then yeah, it's okay.
Yeah, exactly. I was going to say, unless you're using it in a capacity that is really low risk, and so if there's just this wide range of uncertainty around it, or it has the potential to go off the rails, the consequences are not going to be very high. Let me just squeeze in one of my favorite anecdotes on this. There was actually a group here in New York, the New York Mycological Association. So mycology is the study of mushrooms. And they actually sent out an alert saying, do not purchase any guidebooks on mushrooms that were generated or produced by generative AI because they can be harmful or even deadly mushrooms. They can make you misclassify things. And so I thought, well, that's pretty high materiality. But I especially love this story because it definitely puts a new twist on the term hallucination.
I like that, David.
Good one. Okay, and with that, we're a bit past our time, so we'll have to cut it short here. We had a few more questions, but over coffee. And
I'll be around, so if people want to.
Same here, and more than happy to answer any other questions you might have. And with this, we're going to, please stay seated. We're going to transition directly to the next panel. Thank you very much.